In this video, we're going to look at a couple of additional aspects of the relational model. First, we're going to look at constraints that we're able to specify on the values of a particular attribute in a table. And you can think of these constraints as criteria that the values in that column must meet. The database system, the DBMS, will enforce these constraints. If we try to add a row that violates one of the constraints, the DBMS will prevent us from doing so. The first type of constraint that we're going to talk about is a uniqueness constraint, and we get one of these whenever we specify a primary key for a table. So if you recall our student table from an earlier video, we had information about students' ID numbers, their names, their addresses, and their emails. And we chose ID as the primary key, and we show that by underlining it in the schema of the table. So because we've chosen ID as the primary key, we're going to get a uniqueness constraint on that attribute. And that means that each row must have a unique value for that attribute. So we won't be able to use the same ID number more than once. So for example, we wouldn't be allowed to add this row, this tuple, to our student table. And that's because we're trying to reuse a student ID that is already in the table. And so that would violate the uniqueness constraint, and the DBMS won't allow us to add that row. However, we are allowed to add this row. So even though we already have a student named Jill Jones, there is no uniqueness constraint on that column, on the name column. And so we are allowed to add this row. The ID number has not been used yet, if we're assuming that this is the entire table, and therefore we're not violating the uniqueness constraint by adding this row. Now, if we have a primary key that is a combination of columns, a combination of attributes, then each row must have a unique combination of values for those attributes. So imagine that we have a table capturing information about movies, and you can see we have one column for the name of the movie, one for the year in which the movie was released, one for the rating, and one for how long the movie is in minutes, the runtime. And we're assuming here that a combination of name and year will be unique, and therefore we have made the combination of those two attributes the primary key, and that's why they're both underlined. So because we have two attributes in our primary key, the uniqueness constraint applies to the combination of values in those columns. So for example, we are allowed to add this row to the movie table. So notice we're repeating the name Ocean's 11, but it's with a different year. So in this row we have the combination Ocean's 11 2001. In this row it's the combination Ocean's 11 1960. And because it's a different combination of primary key values, it's okay to add that row. Similarly, we can add another movie from 2015. Even though we already have a movie from 2015, that's okay as long as the name isn't also the same. However, we would not be allowed to add this row because the combination of name and year is already in the table, and so we can't have another row with that combination. The next type of constraint is what's known as a referential integrity constraint. This has to do with foreign keys. So if you remember, in our previous video we had an advisor attribute in the student table that was taking on values from the ID column of the faculty table. And we were using that foreign key, advisor, to capture the relationships between students and their advisors. So every time we specify a foreign key, we get one of these referential integrity constraints. And what it says is that the foreign key attribute, or if there's a combination of attributes making up the foreign key, must take on values that are already in the corresponding primary key. So for example, if we wanted to add this row to student, we look at the foreign key value, the one we're specifying for advisor, 22222, that is not already in the faculty ID column. and therefore we're not allowed to do that. It violates referential integrity. There is no way to refer to a valid faculty row, faculty tuple, using this number because there is no faculty member who has that ID. If we look at this tuple, however, the primary key value is fine, so uniqueness constraint is not a problem. And if we look at the foreign key value, the one for advisor, that does refer to a faculty member because that value is being used as an ID number for an existing faculty member, and therefore we are allowed to add that tuple. Our next topic is the notion of a null value. If you recall, all values in a given column must be of the same data type or come from the same domain. And by default, a data type in the relational model is going to include a special value called null. We use null values either to indicate that the value of a given attribute is unknown for a particular row, or that there is no value for that attribute in a given row. One example of this would be if we had a column for capturing a student's major, we could use the value null to indicate that the student doesn't have a major at the moment. Now it turns out we cannot put a null value in a primary key column because then we wouldn't have a way of identifying that row. Remember, the primary key is being used to uniquely identify each row. We are allowed to put null values in foreign key columns. And this is true even though null won't be in the corresponding primary key column. This allows us to indicate the absence of a relationship. So for example, if Alex Hamilton is a student and does not have an advisor, we can put null in that foreign key column to indicate that that student does not have a relationship to a faculty advisor.